Greetings, traveler. I'm the calculus clerk, and today we'll be working with differential equations. So the specific problem is to use Euler's method to approximate the given value of y of t with the time step h indicated. So Euler's method is a very complicated sounding formula that's really just broken down into this. So y of k negative 1 is the previous y answer from before. So like if I was going to take let's say y of 3.1, and the previous one was y of 3, then you replace this with the y of three's value, which is 1 here. This is arbitrary. But anyway, this is previous term. And then h is your given. It's the time step. It's how farther along the y value you're stepping along. So if you start at 3, you add 0.05 to the next step. So Euler's method is a formula based on steps. And this complicated thing over here is just the slope with the previous inputs. Say we're taking y of 3.05. This is like the correct step now. And then y of 3 is equal to 1. That's our given. That's the previous step before. So we plug in 1 into there, into the previous term. We plug 0.05 into the h. And then for the previous slope, this over here is our stand-in for the slope equation, because y dot y, as I call it, is dy over dt. It's the same thing. So you can replace this. The t is replaced with the 3, and the y is replaced with the 1. And you figure it out from there, and you just plug that previous slope right in here. Hopefully it'll get much more clear when we start unpacking the problem. So always we start from the given y of 3 is equal to 1. So that's our given starting point, and then we take one step. So we add 0.05 to that 3. So y of 3.05 is our next step. Taking the equation from earlier, we plug in 1 into the y of k negative 1, the previous y term, which is 1. That goes there. And then you add that to the h value, 0.05, all multiplied by the previous slope. So the t value is 3 from this previous term, and then the y value is 1. And so that is your 3.05 value. And then you solve this all out. I recommend using a calculator, because once we get towards the end, it's going to start getting really messy really fast. And we want to keep all the exact answers in our minds. This one is relatively simple for now. By the next step, it's going to get a lot worse. And then add 0.05 to this 3.05, which will give you 3.1. So as you can see, we're stepping our way all the way to 3.3. And so the previous value is 1.4 plus the h value, 0.05, multiplied by the previous slope. So we plug in the t from here into there, which gives us 3.05 squared. We plug in the y value we just found over here back into that y value over there, negative 1.4. Do you understand why it's getting very complicated very fast? You could box your answers to keep track of it better. It's up to you. And then use your calculator again to figure out the new value. And I got 1.795125. Okay, with Euler's method, you do not want to approximate early. You want to leave the approximation for the very last step. So store all the answers in your calculator. I mean, you could write it approximately on your paper, but for me, I write it all out. I write the full thing out, so that way I don't make a mistake and plug in the wrong y value into my calculator. Because when you approximate too early, you can distort the answer, because we're going to step a lot more. So by the time we reach the final step, it's going to be a completely different y value than if you used the full answers, like the whole way down. And then add 0.05 again, 3.15. So it's just long and tedious. 1.795. You can approximate it when you write out your next step. Just remember to keep the answer in your calculator the same. So you can just use the answer key to do the steps. And then the previous t value was 3.1. And then subtract that from 1.795, which is not really 1.795. 0.05 multiplied by 3.1 squared minus answer. Okay, and I got 2.1858687.5. add 0.05, 3.2, 2.186 plus 0.05. Once again, approximating on here, but not on the calculator. 3.15 squared minus previous 2.186. Make sure to answer. And on the calculator, I'm going to put an answer plus 0.05 multiplied by 3.15 squared. Negative answer is equal to 2.572700313. Okay, and next we will go over to 3.25, because we're adding 0.05 once again, and 2.573 plus 0.05 multiplied by 3.2 squared minus 2.573. Plug that back into the calculator. So answer plus 0.05 multiplied by 3.2 squared minus answer is equal to 2.956065297. And then the last step, add 0.05. That gets us to 3.3 is equal to 2.956 plus 0.05, 3.25 squared minus 2.956. Okay, plugging that into the calculator, answer plus 0.05 multiplied by 3.25 squared minus answer. That is equal to 3.336387032. Now they're asking us for an approximation. So for y of 3.3, it's fine to give them an approximate answer. So just say that's like approximately, take it out to the third decimal, as that's what we have to do in calculus, or the thousands place. And y of 3.3 is approximately 3.336. And that is our final answer.